Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 30. Today we'll be talking about polygon sums more. Last lesson we discovered there's a pattern for the interior angle sum of polygons. But what about the exterior angles? Is there a pattern? So our first investigation, we're going to need paper, pencil, and protractor. You want to draw 3 different size polygons with 4 sides each. Extend each side to form one exterior angle per vertex. Carefully measure all the interior angles except for one, because we can use our polygon sum conjecture to calculate the last angle. Then you can check that one by measuring with a protractor. Use the linear pair conjecture to calculate the measure of each exterior angle. Remember that the interior angle and the exterior angle are going to be on a line, so they are a linear pair, and a linear pair would add up to 180. After you calculate the exterior angles, add the 4 exterior angles together. What is the sum? As you do your 3 quadrilaterals, is the sum the same? So now then repeat the investigation with pentagons. Do you think that you will get the same sum? Will it be higher or lower? After you do this with pentagons, think about what hexagons or any other polygon might be. What is the pattern that you see? Here's 4 points that I'm going to draw a quadrilateral with, and I'm extending each line in one direction to get my exterior angles. Now I'm going to measure each of my interior angles. I'm then going to calculate my last one, and then I'm going to calculate my exterior angles. I can then add them together, and I get 360 degrees. Here's another quadrilateral. Also, the sum of the exterior angles is 360 degrees. Here's some pictures of my pentagons. Even though there's 5 angles now, the exterior sum is still 360 degrees. So let's think about a triangle. If it was equilateral, we know that each of the interior angles will be 60. If we do 180 minus 60, we'd get 120. If we add 120 3 times for these 3 exterior angles, we get 360. So do you think that the exterior angle sum will always be 360 for any polygon? If you said yes, you're right. The exterior angle sum conjecture is that for any polygon, the sum of the measures of the set of exterior angles is 360 degrees. So what about polygon angles? From our interior angle sum formula, we want to find a formula for the measure of one interior angle if it's an equal angular polygon. We're going to use n for the number of sides. So from our last lesson, we knew that we had n minus 2 times 180 degrees for the sum of all the interior angles. If we want just one of them and they are all equal, we could divide by the number of angles, which is the same as the number of sides. If we put our algebra to it, we could distribute this 180, and we would get 180n minus 360 divided by n. And then over here, these n's will divide out, and we would have 180 minus 360 over n. So either of these would work for our formula for the measure of one interior angle when it's an equal angular polygon. From our exterior angle sum conjecture, what's the formula for the measure of one exterior angle if we have an equal angular polygon? Well, our exterior angles always add up to 360 degrees. So we just had to divide that by the number of exterior angles. So our equiangular polygon conjecture is that we can find the measure of each interior angle of an equiangular n-gon by using this formula. So again, you can start with the 180 times n minus 2. I like this one because I remember that there's 2 less triangles than there are the number of sides in each polygon, and then I just have to remember that it's 180 for each triangle. And then divide that by the number of angles, which is the same as the number of sides. But you could also use the formula when you distribute and divide, which would be 180 minus 360 over n. A regular polygon is a polygon with equal measures for each of its sides. So an equilateral triangle and a square are both examples of regular polygons. We know that an equilateral triangle and a square all have the interior angles measuring the same. This will be true of any regular polygon. Because the sides are all equal, the interior angles will be all equal. So a regular polygon would also be an equiangular polygon.